Good evening. Welcome to Rational Numbers, Opposites, and Absolute Value. Our focus question today, when is it helpful to use a number's opposite? So let's talk about rational numbers. We'll move right into it. A rational number is a number that can be written in the form a over b or negative a over b, where a and b are whole numbers and b is unequal to 0. You can also think of rational numbers as the whole numbers, fractions, and decimals you already know, and their opposites. I like to think of it this way, in a very non-technical way. A rational number is a fancy word for a fraction. A divided by b, or a over b. Okay, and of course it's negative. So take a second, and I want you to stop and think of all the different types of numbers you know. Start thinking of numbers and naming some numbers to yourself. Here are some numbers I'm naming to myself. 0, 2/3, negative 1.6, negative 3 1/3, and 5 7/100. Okay? Come up with a whole bunch of different numbers. You may have different numbers, and there may be some others that I haven't listed here that might not be rational numbers that you're thinking of. But right now we're going to talk about rational numbers. So, each of these numbers can be written as a fraction. 0, I can write 0 over 3, or 0 over 10, or 0 over any number, as long as the number I'm writing it over is not 0. I can't have 0 over 0. 2/3 is already written as a rational number. However, think about this, it is the repeating decimal, 0.6 repeating. So repeating decimal could be a rational number. Negative 1.6. If I want to put it into fraction form, it's negative 1 6/10, which I can simplify to negative 1 3/5, which I can convert to negative 8 over 5. Still a rational number. The next one, negative 3 1/3, that would be negative 3.3. Repeating. This repeating part tells me that it can still be a rational number because all repeating decimals can be rewritten in the form of a fraction. But let's convert this. Let's cut right to it, and we get negative 10 over 3. And the last one, 5 7/100. That's really the way we would write it as a complex number, or as a mixed number. And so when I convert this, I get 507 over 100. Okay? So let's think a little more in depth about these numbers here. We have rational numbers, we have integers, and we have whole numbers. Whole numbers are a subset of integers, and integers are a subset of rational numbers. So these are all subsets. Okay? So, remember, rational numbers and fractions. Okay? Integers are special rational numbers. Integers are rational numbers whose denominator is 1. Okay? These include positive and negative numbers. Okay, so if we look at our examples, negative 3, because I can write it as negative 3 over 1. Negative 2 would be negative 2 over 1. 2 would be 2 over 1. 0 would be 0 over 1. Okay? And whole numbers are a subset of integers, which also makes them a subset of rational numbers. So whole numbers include 0 and positive integers. whole number is an integer and a rational number. An integer is also a rational number, but it doesn't work the other way. Not all rational numbers are integers, okay? Like this example here, the negative 0.7 is negative 7/10. This is a rational number, but not an integer. So I want you to take a minute, and I want you to write each one of these into their proper category. Whole numbers, integers, and rational numbers. Okay, so my whole numbers are 13 and 0. My integers are negative 7, negative 125, 13 and 0. And all of them are rational numbers. Now, if we wanted to say which would be the most appropriate representation of the numbers, or the most appropriate way to classify these, I would not include 13 here in my integers. 13 is more specifically a whole number, okay? And negative 7 is a rational number, but it'd be better to classify it as an integer, okay? Just to make that clarification. So, to which set of numbers does negative 1 3/5 belong? It's not a whole number. It's not an integer, but it is a rational number. I could rewrite it as negative 8/5. It's rational. So one of your friends says the number 4/4 belongs only in the category rational numbers. Another friend says it belongs in each category: whole numbers, integers, and rational numbers. Who is correct? Well, this looks just like the last slide, this slide here. Same concept. The second friend is correct. This friend here, our second friend. Because 4/4 simplifies to 1. And 1 is a whole number, an integer, and a rational number. Absolute value. The absolute value of a number is its distance from 0 on the number line. The symbol for absolute value of a number n is these 2 bars. We write the number inside these 2 bars. 2 things to always remember. Distance, always positive. Okay. And when we write our absolute value sign, please make sure we write them big enough. So if we were to write the absolute value of 3, we don't want to write it like that. This looks like 131. We want to make sure we make these large enough. Okay, just so you don't screw up later on. We don't want you to make a silly mistake. So the absolute value of 2 is 2. Here is 0. How far away am I? It's 2 units. Negative 1.4. How far away is it from 0? Here's negative 1.4. How far did I travel? 1.4 units. Okay? Absolute value of a positive number is the number itself. Okay? You might want to write that down. Absolute value of a positive number is the number itself. Absolute value of a negative number is the opposite of the number. Okay? One more cool thing. The absolute value of 3/2 is 3/2. I'm right here. Sure, if I want to go 3/2, there we go, 1.5 units away from 0. The absolute value of negative 3/2 is 1.5 units away, or 3/2 units away. If I look at that, 3/2 and negative 3/2, they're both 3/2 of units from 0. Okay? So 2 numbers that are opposites have the same absolute value. These 2 numbers here and here are opposites, but their absolute values are the same. Okay? Moving right along. Complete each statement with the symbol that correctly compares the absolute values. So your choices, of course, are greater than, less than, or equal to. Take a second to fill those in, and we'll be back. How did you do? Do you agree? If not, go back and check. Make sure when you take the absolute value of -5, it's +5. The absolute value of 3 is still 3, so now we're comparing 5 and 3. And the same the rest of the way through. Now, we can use positive and negative rational numbers to represent changes in real-world quantities. Two changes represented by opposites result in no change. For example, we start the morning out at this temperature here, we rise 20 degrees, but by nightfall we fall back down 20 degrees and we're right where we started. Technically, no change. I put $10 into my piggy bank and then I take $10 out of my piggy bank. The amount is right back to where I started. Here, I let my hair grow. I get my hair cut 1 3/4 of an inch, and then it grows back out. So no change from where I originally started. One I always like to think of is elevation. Throughout the day, you run upstairs, you run downstairs, you do all sorts of different things. When you get up in the morning, if you start your day out in your bed, and then end your day in your bed, you might have gone up and down, but at the end of the day, your elevation is right back where you started, right in bed, okay? Write a positive or negative number to represent the change described in each situation. Describe the opposite change in words with a number. So, let's look at this here. We climb up 7 stairs. That's a positive 7. The opposite would be a negative 7. What's the opposite of climbing up 7 stairs? Descending 7 stairs. Or going down 7 stairs. Okay. Our car uses 9.2 gallons of gas. That's a loss. The opposite would be gaining 9.2 gallons of gas. And how do we gain gas? We fill our tank up. We put 9.2 gallons of gas in the tank. And the last one, a submarine descends -3/8 of a mile. So we're going to ascend 3/8 of a mile. Now, we said earlier, distance can't be negative, okay? Here I'm talking about a distance. -3/8 of a mile, this is going to help lead us into our next topic. The negative sign represents a direction, okay? To descend, go down, direction. It's a negative number. We're not traveling a negative distance, we're still traveling a positive distance, but the negative just tells me the direction, okay? So let's go back to our focus. Going through individually as opposed to in the beginning. Okay, here we go. All right. So when is it helpful to use the numbers opposite? If a number describes a change in quantity, then the opposite of the number describes how to reverse the change. And there's our focus question for today. All right, I hope you have a great night, and I'll see you guys in class, you guys and girls in class tomorrow. Have a good one.